In this lesson, we're going to be analyzing quadratics. And normally when you deal with quadratics, especially in Algebra 1, most often you see them in this standard form here. Negative 3x squared plus 12x minus 9. Looks something like that. And then they also taught you what we call vertex form, which is this second format here. And notice on here I have it in both ways. On the first one, we just have it in vertex form. But what we're going to do is we're going to go ahead and analyze this. We're going to graph it. We're also going to go ahead and determine what our vertex is, our axis of symmetry, and determine if it has a max or minimum, its domain, its range, and its roots. We're also going to fill out this table, our x and y values of it. Now, to graph any quadratic, you got to have at least 3 points. But I did leave space for 4 points in here because we're going to go ahead and put 4 on our table. But with any 3 points, you can graph it. Now, one thing I like personally about vertex form, which is the form that we see this one in right here, is that it tells you right away what the vertex is. Now, what I want you to think about is when you're dealing with the vertex, you just need to remember the rule that anytime that you have a quadratic in vertex form, this is similar to what we call our vertex is going to be made up of an x and a y value. So let me go ahead and write that down. Actually, I'll do my x in orange and I'll do my y in pink. And we like to use, when we're talking about this vertex form, we actually like to use the variables h and k. In other words, they represent our x and y value. Now, you may be looking at it going, well, Mr. H, that doesn't really help me. You told me an h and k, but up here I don't see any h and k. Well, let me go ahead and write out the vertex form formula, just so you can see what it looks like, and then you'll be able to identify what those values are. Now, if I went ahead and I wrote this instead of y equals 3x minus 2 squared, if I wrote it differently and I wrote it as y is equal to a times x minus h squared plus k, then it's a little bit easier to determine what's what. In other words, this h right here is represented by this value of 2. And the k right here, notice there's no k at the end, which means it must be plus 0. Because in math, anytime something's 0 and we have it in an equation, we often just leave it off. So we know what k is. We know k is 0. So I'm going to go ahead, I'm going to write my vertex here. I know my k value must be 0 because we don't have a number written at the end of it. And I know my h value is going to be 2. Now I'm going to put a 2 right here. So this is before you even started, before even really doing any math, we can just simply determine what our h and k is on any of these. Now I'm going to go ahead and I'm going to plot that point because that is going to be one of my points for my graph when we graph it here. And so I'm going to go over here and let's see, my x value is going to be 2. So notice this is my x-axis. And then the vertical axis that runs up and down is my y-axis, right? So I want to go ahead and go over 2 times. 1, 2. And notice the y value is 0, so it stays right there. So I'm going to go ahead and put a point right here. And I'm going to write that ordered pair again right underneath it. 2, 0. And beneath that, I'm going to go ahead and write vertex. That is my vertex. Now, we need 2 more points in order to graph this. So there's a couple different ways that you can go about that. One of the easiest ways is to simply put it in a calculator. But sometimes your teachers are going to have you go ahead and do this by hand. So I'm going to show you, if you're asked to do this by hand on the test and you didn't have the calculator, I'm going to show you how you would do that. So I'm going to rewrite this, y equals 3x minus 2 squared. Over here, the only difference is I'm going to leave out the x because we're going to replace that x with a value. So I got y equals 3 parenthesis, and instead of x, I'm going to put a second set of parentheses, and we're going to replace this x with a value. Now I already know that my vertex is 2 and 0, so I'm looking at it going, well, you know what? Let me go back over to 1, and what is the y value when x is 1? And if I want to know that, I can simply replace my x value, right? That 2 right there. I'm going to replace it with a 1 and this will be minus 2 parenthesis squared. And I'll work this out and see what y is when x is 1. And that's going to tell me where I should put my point on this 1 value for the x-axis. It'll tell me what the y value is, so we can plot a second point. Now I am going to do this with the calculator, just for simplicity as far as the mathematics goes. I'm going to go ahead and let me go over here, and I'm going to type in just what's on the right side of the equal sign. So 3 parenthesis 1 for my x value in my ordered pair, and then minus 2 close parenthesis, and we're going to square it. And notice it gives me 3. So what this tells me here is it tells me when x is 1, my y value will be 3. So now we can plot that point. So I can go over here and go over to 1, right? Positive 1. When x is 1, my y value will be 3. 1, 2, 3. Put a point right there. And I'm going to simply label this one just in black, 1, 3. That's that point, that ordered pair. So now, let's say, you know what? I need 3 points to graph it, so I need to be able to go over here to the right and find this next point. Now, just as knowing what I know about parabolas, if 1, 3 is right here, most likely this is going to be my point. Over here to the right, actually it should be my point because there's a line of symmetry, which means it has to be the same. But if I wanted to show it mathematically for my teacher, I could just say, okay, well, let me go over to the x value of 3, right? Because this was 1, this is 2, and this is 3. So my x value of 3, and I'm going to substitute it, and I can calculate it as well. So 3 parentheses, put another set of parentheses. We're going to put a 3 in there in just a second. So when x is 3, we're going to determine what the y value is. So once again, I'm going to get my calculator, and I'm going to type this in. So I have 3 parentheses, put a 3 for my x value, minus 2, close parentheses, squared. Hit enter, and it tells me that it's also going to be 3. So I'm going to go ahead and I'm going to plot a point there real quick. So at 3, 3. And now we can go ahead and we can draw a parabola. So I'm going to go ahead and draw it real quick. Right, so this one down here is my vertex. And then we go through 3, 3, and we go up. And start at my vertex, and we go through 1, 3, and we go up. And there's my graph. That's my parabola. Now I'm going to go ahead and put these points into my table that we figured out so far. We said that we knew that over here we had 1, 3. So I'm going to put in my x and y values. So we have 1 and 3. Then our vertex is at 2 and 0. And then we had a point at 3 and 3. And for the last point, I'm just going to use my calculator to check on my work, because what if I made a mistake? So let me get the calculator. I'm going to go ahead and go over to the graphing feature by hitting y equals, and I'm going to type in this entire equation here. Now we already have the y and the equals. I just need to put 3 parenthesis x minus 2 close parenthesis squared. So 3 parenthesis x minus 2 close parenthesis squared, and hit graph. And there's the picture. Notice it looks just like what I graphed here. Now I'm going to hit second and table to go ahead and pull up my points, and notice we do have our vertex. And one of the ways you can always identify the vertex is notice that we had a 3 for our y value, and then we had a 0, and then we had 3 repeat itself. When you see that y value repeat like that around a single digit, you know that the one that's in between it is your vertex. So our vertex is 2 and 0, and we had already determined that, right, by just looking at the 2 and the 0 in the equation. And then one of our points is 1, 3. We had already graphed that, and we had calculated it by hand. And then we had 3, 3, which once again we had calculated by hand and found that. Now I just need one more point, and so I'm going to go ahead and go to this next one, which is 4, 12. So I'm going to simply add that in there. Let's say this is 4 and 12. So now my table is complete, And if your teacher gave you a bigger table to fill out, right, you can use this table, just scroll up and down, and you can put as many points into the table as you need to once you graphed it. Now, a couple things I want to talk about is we want to talk about our axis of symmetry. The axis of symmetry is an invisible line that just cuts your image in half in two equal parts, or two parts that mirror one another. And so my axis of symmetry is right here. And the neat thing about knowing your vertex is the vertex, when you look at its ordered pair, the x value is always going to be your axis of symmetry. And I just went ahead and drew the axis of symmetry with my highlighter. And I'm going to label it real quick. I'm going to go ahead and draw an arrow pointing right there. I'm going to write axis of symmetry. And it's always in relation to our x value. So for my axis of symmetry, I will simply put x is equal to 2. And notice all I did was take my 2 value of my vertex, and that is my axis of symmetry. Now, we also need to know, does this have a minimum or maximum? Well, if it's a maximum, then your parabola is facing down. It opens downward. And if it's a minimum, it opens and faces upward. In this case, we have a minimum. This is the minimum value. And so that's always in relation to y. So first of all, I'm gonna circle minimum, cross out max, and then it's in relation to y, and it's when y is equal to 0. So the value right here for y, for your vertex, is always going to be your minimum value or maximum value. So I'm going to go ahead and write y is equal to 0. So notice we use the x value out of the vertex, and we use the y value out of the vertex to give our axis of symmetry and the minimum, because right, this is at the very bottom of the graph. Now we got to give our domain and range. So when we talk about our domain, notice we have an arrow here, and that arrow means we go infinitely to the left, and this arrow going over to the right, slanting up and right, means we go infinitely to the right. So we're going to use our infinity symbols. And when we use an infinity symbol, we're going to go ahead and just put a parenthesis, and we'll put negative infinity, comma, positive infinity. Now, another way that we could have stated this is we could have said it was all real numbers. And there's a symbol for all real numbers, and it basically looks like an I attached to an R. So if you see this symbol, it's basically the same thing as negative infinity, positive infinity. It just means all real numbers. It means it goes forever to the left and forever to the right. So that is our domain. Now, when it comes to the range is going to be, we want to look at the furthest it goes down, and the furthest this one goes down is actually 0, right? Once it hits 0, it doesn't go down any further. So we're going to write this as an inequality. And so if I wrote it as an inequality, we would just simply write y is going to be greater than or equal to 0. Now, if we wanted to write this as in what we call interval notation, right? Because I'm going to write this in two different ways. We could also simply write this as, and I'm gonna put a line here to kind of break it up. I notice I wrote this one underneath the bottom. Hopefully it doesn't create any confusion. But over here, if I wanted to write it, I would just simply go ahead and recognize that the lowest it goes is going to be 0. So I would go ahead and put a bracket and put 0, and then comma, and then I would put positive infinity and put a parenthesis. So this right here is going to be interval notation, and this is as an inequality. Up here, this is interval notation, and this is as a statement, right? Which is not an inequality, but it just states all real numbers. Now, the last thing that we got to talk about, notice, is this word right here, the root. And the root is just another word for our solution, right? So I want you to remember this. When we say root, it's just the solutions to our problem. Sometimes instead of calling it the solution, we may call it the X-intercepts. And another word we like to use for it that's interchangeable is zeros. Now, some of you may looking at it be like, well, you know what, Mr. H, it looks like it just touches one time, so we just have one solution. Well, it actually does have two solutions. We say that it has double roots. There are two solutions, but they happen to be the same value, right? So every quadratic can have two solutions, but it can be at times the same value. And so we're going to call this, because this has a single point that's touching the x-axis, we're actually going to call it a double root. That's just a term that we use, showing that both of our answers are going to be the same value. And in this case, right, this one right here, notice that it is going to be the value, the x value at where it crosses. In other words, it's going to be 2. So if we were to write this answer and it said, what are the roots? I would go ahead and write 2, comma 2. Those are our solutions. In other words, if we were writing it as a 0, we might simply write it as x is equal to, I'll move this up just a little bit, 2. And x is equal to 2. Alright, so let's look at this next one. On this next one here, right, I wrote it in standard form and I have it in vertex form. But I'm going to go ahead and use the vertex form because I feel like it's more useful, because I can go ahead and find my vertex very quickly by looking at it. Notice right here, I'm going to circle that value. That is my x value in my vertex. So it's going to be a 2. So when it talks about the vertex, let me go ahead and write my ordered pair. And I can say with confidence we're going to have 2 for our x value. And then notice over here at the end it says plus 3. So that's going to be my y value, right, or the k value. So I'm going to go ahead and I'm going to write 3 for that one. So let me plot this point. I'm going to plot the vertex real quick. It's at 2, 3. So over 1, 2, and get me a colored pen. So 1, 2, and then up 3. 1, 2, 3. So I'm going to put a point right there. And we'll go ahead and we'll write the ordered pair for it. So the ordered pair for this is going to be 2, 3. Because that's its location. Now, that's also, we already know, without even graphing anything, we already know that the axis of symmetry, that it's going to go straight through this point, right? It's going to be in relation to x, and it's going to be the x value of my vertex. So I can go ahead and say x is going to be equal to 2. And we need to graph it to determine if it has a maximum or minimum. If you can't tell by looking at this if it's going to have a max or minimum, graph it. And I recommend always graphing it just to make sure that you don't make a mistake. So let's go ahead and let's graph this equation. So this one I'm not going to work it out by hand. I'm simply going to go ahead, put it in the calculator, and we'll take a look at it once we graph it. So I'm going to clear out what I had in there. I'm going to type in -3, parenthesis, x minus 2, close parenthesis, squared, and then plus 3. Hit graph, and you can see the graph is going to appear in just a moment. And notice that it's upside down. So in this case, instead of it being a minimum, it is actually the maximum value. And so I already know I'm going to circle max because I'm going to have a maximum value. I'm going to cross out minimum. We are not going to have a minimum value. And it's going to be y is equal to 3, right? We just take the value from our vertex that represents k, and we write that as our maximum value. That's the highest our graph is going to go. Now notice I haven't plotted my other 2 points. I'm not going to do it by hand this time. I'm simply going to hit second and graph to get my table, and I'm going to find the vertex. So looking at it, my vertex is 2, 3. So notice I have zeros on either side of it. And so the other 2 points I'm going to plot are going to be 1, 0 and 3, 0. So let's plot a point at 1, 0. So this is 1, 0. And then 3, 0. So 1, 2, 3, and that's 3, 0. So we're going to go ahead and we're going to fill in our table real quick. So far, the points that I have 1, and we have 2, and we have 3, right? 1, 2, and 3. Those are my x values. And my y values that go with each one are 0, 3, and 0. Now if I wanted to add one more point, I can go ahead and go down to 4, and I got 4 and negative 9. So let me write that down, just so we can have a full chart. 4 and negative 9. Now we are almost done. We can go ahead and we can graph this real quick. So I am going to graph it. So that line goes down. This one also goes down, just like our picture in our calculator. Now what I want to do is it asks me, it says what is the domain? So I'm going to first write the domain in interval notation. So let me go ahead and write my brackets. Now I want you to notice why this goes down, it also goes to the left. And why this goes down, it also goes to the right. So it goes forever to the left and forever to the right. So therefore, we're going to have negative infinity positive infinity. The other way that we could say it was we could just say it's all real numbers, right? So if I want to do all real numbers, I would write it like this. So whether you see this symbol for all real numbers or you see negative infinity infinity, it is the same thing. It just means every value that's left of origin and every value that's right of origin. All of it's going to be covered. Now I can also go ahead and write my range. I'm first going to go ahead and write it in what we call interval notation. Now I know that in this particular point I have a maximum, right? And the highest it goes is 1, 2, 3. So that's the highest it goes. And so when I write the range on there, I can go ahead and put my parenthesis, because notice I'm not going to put a bracket yet, because when we always want to put the how far it goes down first. So I'm going to go ahead and put that the furthest it goes down is going to be negative infinity, because it's for eternally going down, right? Forever, infinitely, comma, and the highest it goes up is positive 3. So I'm going to put a positive 3 and put my bracket, because it can actually touch that point. Now the other thing I could do, right, is I could write this as an inequality, and so I'm going to write that kind of underneath, in this space underneath, and I'm going to put, it could be this, or we could say y is going to be less than or equal to positive 3. So both are correct. This is interval notation on the top, and this is written as an inequality on the bottom. Now the last thing we have to do is find our roots. And in this case, our roots, we actually have two different roots. So I want you to notice that one of my roots is right here on the x-axis, and it's going to be 1. So when I write my roots on here, I'm going to go ahead and write me a set of parentheses. And I will simply write a value of 1. That's one of them. And then the other root is right here, and that value is 3. So I'm going to put a 3 on the right. So it's not a double root, right? The other one we had a double root. We had two solutions, right? But they were both at the same point. So we had 2 and 2. This one, it's clear to see that these are at two different locations. So we still have two solutions, but it's not a double root, right? Because we have two different values. So we had a value of 1 and a value of 3. Now if we were to write this as zeros, right, kind of like we did on the other one, if I move this up, right, because remember they're also called zeros, X-intercept solutions. So if we wanted to write it as a 0, we would simply say x is equal to 1 and x is equal to 3. So our roots are 1 and 3. Notice I did go ahead and add my highlighted line for my axis of symmetry as well, cutting through the vertex. And that's all there is to it.